Okay, let us continue with Tech Talks Education. We are continuing with the calculations involving equations, but in this case, we are going to write the equation by ourselves. And there is some bit of thinking that we must involve in this case, because I will give you a mixture of substances and we must see the ones that react in this case. So let us look at this question here. When 10 grams of a mixture of sodium carbonate and sodium hydrogen carbonate was heated strongly until no further change, 1.2 cubic decimeters of carbon dioxide was produced at room temperature. Full stop. A, write equation for the reaction. And then in the next part, calculate the mass of sodium hydrogen carbonate in the mixture, given that sodium is having a relative atomic mass of 23, oxygen with 16, hydrogen with 1, and then 1 mole of a gas at room temperature has got a volume of 24 cubic decimeters. Fine, we are good to go. So in this equation here, in this question, we have been given a mixture of sodium carbonate and sodium hydrogen carbonate, which was heated strongly until no further change, and they have said that 1.2 cubic decimeters of carbon dioxide was produced at room temperature. So we should write the equation for the reaction. We are supposed to be able to know which substance out of these two decompose to produce carbon dioxide. Now, sodium carbonate is thermally stable. Even if you heat it for so long, it will not decompose. But it is the sodium hydrogen carbonate that will decompose and produce carbon dioxide. So if we have been asked in this case, like we write the equation for the reaction, we shall write the equation for the decomposition of sodium hydrogen carbonate, but not sodium carbonate, because sodium carbonate cannot decompose when heated. So let us write the equation. Sodium hydrogen carbonate decomposes when heated to sodium carbonate. It also produces water and it produces carbon dioxide. Let us balance this equation. We have one sodium atom on the reactant side. On the product side, there are two. So we multiply sodium hydrogen carbonate by 2. Hydrogen atoms are 2, On the reactant side, on the product side, they are also 2. Carbon atoms 2. This side we also have 2. Oxygen atoms are 6. Here we have 3 plus 1 is 4 plus 2 is 6. So this is the equation for the decomposition of sodium hydrogen carbonate, which is the equation for the reaction that took place. So there is nothing like decomposition of sodium carbonate, but it is only the decomposition of sodium hydrogen carbonate because it is the one that can decompose to produce carbon dioxide gas. Let's go to the next part, part B. Calculate the mass of sodium hydrogen carbonate in the mixture. So what we are going to do, we are firstly going to get, in fact we are going to get the mass of sodium hydrogen carbonate that decomposed completely to produce 1.2 cubic decimeters of carbon dioxide gas at room temperature. So we are supposed to calculate the mass in this case, and we have been given the volume of carbon dioxide gas produced. So sodium hydrogen carbonate, we shall deal with its mass, and carbon dioxide, we shall deal with its volume. So let us go. So we get firstly the molar mass of sodium hydrogen carbonate. Since we are going to look for the mass of sodium hydrogen carbonate but not the volume, so we first get the molar mass of sodium hydrogen carbonate, which is 23 plus 16, plus 1 plus 12, that is carbon, and then oxygen is 16 times 3. This is sodium 1 atom, hydrogen 1 atom, carbon 1 atom, and then oxygen 3 atoms. What is our molar mass in this case? It is 23 plus 1 plus 12 plus 48. And this one gives us 84 grams as being the mass of 1 mole of sodium hydrogen carbonate. So let us now get the mass of sodium carbonate that produces 1.2 cubic decimeters of carbon dioxide. We are looking for the mass of sodium hydrogen carbonate. And what do? Sodium hydrogen carbonate goes to the right hand side, carbon dioxide comes to the left hand side, but we start with what we are seeing from this equation. So there is 1 mole of carbon dioxide gas produced, meaning that we shall have carbon dioxide gas on our left hand side, and 1 mole of carbon dioxide at room temperature is 24 cubic decimeters. So 24 cubic decimeters of carbon dioxide is produced by, because it is a product in this case, it is produced by, then sodium hydrogen carbonate, 1 mole is 84 grams, but for the 2 moles as per this equation is 2 times 84 grams. And then what of the 1.2 cubic decimeters of carbon dioxide? This one is produced by, then we cross multiply 2 times 84 times 1.2, and we divide it by 24, and the unit remains grams of sodium hydrogen carbonate. And let us see our answer here. So it is 2 times 84 times 1.2. We divide by 24. And we have 8.4 grams exactly. So that is the volume of, that's the mass of sodium hydrogen carbonate that reacted. Meaning that if we were asked to get the percentage, if we were asked to get the percentage of sodium hydrogen carbonate, not only the mass, in this mixture, it would be this mass of sodium hydrogen carbonate out of the total mass of the mixture times 100, and you get the mass of sodium hydrogen carbonate. And for the mass of sodium carbonate, what we will do is we will subtract this 8.4 from 10, and out of the total mass, which is 10 times 100, and we get the percentage of sodium carbonate in this mixture. So you need to be very keen when you're given such a question, because you may find that in the question, one of the substances does not undergo the reaction. It is only one of the substances that can react. So you need to know, if you are writing the equation for the reaction, then which substance is going to react out of the two in the mixture and which one is not going to react. And then you should be able to write the equation very well and you balance it. Now, in case the equation was not asked for, still you are required to write the equation for the reaction here, because this is part of the calculations involving equations. You write the equation for the reaction, identify the chemical species to use in the reaction, and then you also need to consider the stoichiometry of the reaction, that is the number of moles of each substance. So that either the mass or the volume of 1 mole you multiply by that number of moles, and you go on until when you get the answer. So this is Step Talks Education. Thank you for watching.